but I already ruined the magic. When did I tell you guys that this stood for area under the curve? What lesson was it?
It was right before simulation.
And I just told you that that stood for area under the curve, just casually. Okay. So because I said no, because you guys don't do integration in physics.
We watched a video
And it had.
that's how you do integration.
Okay.
But you can do integration, so then we found out.
Okay. So since I ruined it, I'm gonna do the proof tomorrow about why this means area under the curve and why it also means antiderivative. That's called the fundamental theorem of calculus. So for now, since I already ruined it, I'm just gonna go ahead and talk about definite integrals, which just means area under the curve. So it's supposed to be easy. So that way, worst case scenario, today you'll come out feeling really great, and tomorrow if you don't understand it, all you got to do is just apply the rule. Cool? Okay. So here we go. So what does this mean? You have three scenarios, all area above the x-axis. So let me go ahead and write what that is. So I'm going to write area of a to b of f of x dx greater than 0, and that means this. I'm going to draw a grid. It doesn't have to be perfect. Here's a, that's my lower limit. Here's f of x, and here is b, and that means all this. So that's what that means, and that since all the areas above the x-axis is going to be positive. Unsigned area is always positive. And that's it. Nothing crazy there. Are we okay so far? Okay. Then we got another scenario, and I'm going to do two sketches of this one. So we have one scenario where you have some above, some below, but you got more above than below. So I'm gonna see if I can make that happen, a reality. Yeah, there we go. A, B. So because you have more area above than below, this one, from A to B, f of x dx, is going to be positive. And then if you have more below than above, like, I hope it's obvious. Bless you. Bless you. Does this look obvious that there's more above than below, that there's more below than above?
Yeah.
Okay. A to b of f of x dx, then it's going to be negative. Nothing crazy so far, right? Don't ask me right now. Ask me later, miss. Okay. All right. Ready for the next one? All area below the x-axis. So here I am exaggerating below the x-axis. That's A and B. I am below the x-axis. And all this area is below. So area under the curve from A to B of f of x dx. Well, this is f of x. We've done nothing crazy, right? Okay, all we've understood now is that we understand that this definite integral, if I have an f of x function, just means area under the curve from A to B. Recognize that this is called the lower limit. This is where you start, and this is where you end. I think I added it, but just in case, I think I added it in the next page, but just in case. Yeah, I did. Here it is. This lower limit of integration is your start. This upper limit of integration is your stop. This is actually called the dummy variable. It can be whatever. It doesn't have to be dx. It can be any letter. It's not going to change the value of your, it can be f of x, f of u, f of l, I mean, whatever. It doesn't matter. It doesn't matter what you call the x-axis. It can be anything. Are we okay? All right. Let's see if we can just apply some rules. Oh, okay. I guess first let's talk about rules. Okay, so here are the rules. Let's see if we can figure out why. So let's look at the first one. And I don't like that they wrote B in the bottom and A in the bottom, whatever. Here's how we'll say it. Area under the curve from A to B of f of x. If I count backwards, I put a negative, and I'm going to write B to A of f of x. Let me see why. Let's see why. I'm going to just draw a random sketch. So here it is, A to B. A to B. So remember that I told you this is where you start and this is where you stop? Well, this one is telling me that I start at B. So if I start at B and I work my way towards A, won't that be a negative answer? Yeah, it will, because I'm accumulating, remember. So if I start at A, add. Oh, stop there. But if I start at B, like you're counting backwards, guys. So if you see the limit starts at a number bigger than what the upper limit is, understand that you're going to be counting backwards. Now be careful. If it's below the x-axis, then it would be a positive number, right? Because negative times a negative is a positive. Okay. And then the 0 one is a simple one to know. Notice that the limit, it starts at A and it stops at A. Have you moved at all? No. So for number 2, just put, quote unquote, put it in quotes, haven't moved. You haven't moved. So how can you accumulate area if you haven't moved at all? Does that make sense to everyone? Yeah, that's like saying this. Find me the area from 3 to 3, and I'll make it simple. I'll put 5 dx. Well, here's how that graph looks. Here's 5. Well, I haven't moved. Here's 3. It's just a point. You haven't done anything. Does that make sense? Okay. Constant multiple. That's pretty basic, guys. I will tell you what that means. If you have something like a 5 in front of the f of x, it's just like limits. You can move it to the outside. We use that a lot, actually. So if there's a constant in front of the f of x, like a 3, you can move it to the outside. And you know what? Let me give you, because some of you guys are looking like, but why? I don't understand. So let's do the easiest shape that you guys can understand area. No, parabola is kind of complicated. A rectangle, right? You can find the area of a rectangle easily. So look, if I have a function like this, here's my x-axis, here's my y-axis. I said the opposite, I know. X-axis, y-axis. I'm going to say 2. So here's my line. Cool? So if I do this, area under the curve from 3 to 7 of 2 dx. Well, all that means, here's 3, here's 7. I want this. That's just a rectangle. Are we still okay, guys? What is 7 minus 3? 4. What's 4 times 2? 8. So that's 8. Now let's say I'm going to call this f of x. So right now I'm doing this. 3 to 7 of f of x dx is 8. Are we still okay? Now look, I'm going to put a number in the front like 3. Well, okay, I shouldn't put it there. I'm going to do it again. So here we go. I'm going to do this. I'm going to go, I want the area from 3 to 7 of 3 f of x dx. Well, according to this property, this one, I can just put that 3 here in the front. So I can write 3 integral 3 to 7 of f of x dx. And then look, this part that I'm putting in brackets, that was just 8. What's 8 times 3? This is 24. Now let's see if this is true. You guys ready? Oh, what happened, Alvarez? Ask. Okay, let's see if this is true. This is just a rectangle. I'm going to call it g of x. G of x is 3 times f of x. What is 3 times 2? So g of x is just 6. Do you guys agree? What if I'm 6 all the time? So here's 6. And now I'm doing the same thing from 3 to 7. Let's see if this area really is that number 24. Well, 7 minus 3, what's that? 4. So this is a width of 4. What's 4 times 6? 24. It worked. Do you guys see that? So all that means, if you have a constant in front of the f, if it's a sum or a plus, that does not mean that. If it's a constant, you can just pull it out. Cool? Okay. All right. I'm going to erase all the. So far, everything is going smoothly. Nothing crazy. Nothing crazy. Okay. Sum and difference. Okay. If I have a function, and I should have left g of x in there, but that's fine. If I have a to b and I have this, I have two functions, f of x plus g of x, with the dx like that. By the way, I know it doesn't make any sense to, like, there should be a parenthesis like that, but in the math world, we understand that this means the start of your integrand, and this dx means the stop of your integrand. So it's understood to be this, f of x plus g of x, all that times dx. That's what it's understood. But if you don't see parentheses, don't freak out. Math people, math textbooks, they've all accepted this as well for the part of the integrand. Cool? Okay. Where was I going with this? Oh, yeah. This, you can separate it like this, guys. As long as they have the same limits, a and b, you can separate it and go like this. A to b of f of x dx plus a to b of g of x dx. And that's it. That's the sum and difference. Yeah, like as long as I'm trying to think about what about logs. Well, logs are a little different because those are like exponents, but yeah, but they have to have the same limits. If they have the same limits, you can do that. All right, now the additivity, that you'll be able to visualize it really quick. So look. And I don't like how they didn't A, B, C, D. Well, that one I guess they did okay. Okay, I have a curve, and I know you can't fit all of them, but that's fine. And I'm going to call this A. I'm going to call the middle B, and I'm going to call the end C. And this curve is f of x. So if I do this, area under the curve from A to B of f of x dx plus area under the curve from B to C of that same curve, f of x dx, equals, well, let's think about what you did. This here in blue is this part right here. Yay or nay? Yes. This part right here in green is this part right here. Am I adding all these still under the same curve?
Yeah.
So I can just write one, instead of having two integrals, I can just write one integral, start at A, and end at C of f of x dx, if it looks like that. What's up? Yeah, go for it. Does that make sense, guys? Nothing crazy. Just make sure you make a note where this one stops, this one better start. See, where this one stops, the other one better start. Yay or nay? Yeah, I think we proved them all, guys. Yeah, we proved them all. 1, 2, 3, 4, 5. Did all that make sense more or less? Okay, all we're doing today, we're not doing the fundamental theorem of calculus, part 1, 2. We're not doing antiderivatives. All we're doing is area under the curves. They could be positive, they could be negative if they're below the x-axis. That's all we're doing. Cool? All right, so here we go. They tell us this. I have some curve, g of t, and they go, I'm in the next page. It starts at -3 and it goes all the way to 0. Perfect. So I know it may be some below, some above. We don't know, but we know that there's more above than below, if in this case. And it's equal square root of 2. Are we still okay? They want me to find these if possible. All right. From 0 to -3 of g of t. Can I figure what that is? Yes. What's the answer? Negative square root of 2. Why? Because, yeah, you're counting backwards. It's the principle. It's the number 1 order of integration. You're counting backwards. Did everyone see how we got negative square root of 2? Be honest. Okay. Letter B. Oh, OMG, look, they changed the letter to a U. Does that change the magnitude? No. So this is going to be what? Square root of 2. Nothing changes, guys. It's a dummy variable. It doesn't matter what you call it. Are we still okay? Roman numeral C. Notice they have a negative on the inside. A -1 like that right there. Can I move that -1 to the outside if I wanted to? Yeah, -1, -3 to 0 of g of x dx. Okay, so that means what? Negative square root of 2. Have I confused anyone? All right. A square root of 2 in the bottom. Remember, this is like 1 over square root of 2. I can move it to the outside like so. Integral -3 to 0 of g of r dr. So this is going to be 1 over square root of 2 times square root of 2, which is just going to give me 1. Are we okay so far? Say it again. Oh, well, right here I have a quotient, and really I can make this on the inside look like 1 over square root of 2 times g of r. And now this 1 over square root of 2 is just a constant, and because it's a product, I can just take it outside the integrand. You know what I mean? Does that make sense, Gonzalez, or you don't like that? You don't like it? Yeah, the only reason I can do that is because there's no plus or minus in the top. If I had two terms, then I would have to do something. Well, I guess you can still factor out a square root of 2 from both terms. But yeah, if it's like this, I'll have one term on the top, a square root of 2 on the bottom. I can just pull it out. That's a fraction, but make sure that it stays in the bottom. Yes, this right here in a bracket. That is square root of 2. Because they gave me that, right? Okay, let's go to the next one, guys. It's getting, yeah. Here we go. It's getting more complicated. Ready? So I have two functions now, f and g. I don't know how the graph look. I can tell between 1 and 2. Just because it's negative 4 does not mean that it's always below the x-axis. I could have some above the x-axis, but there's just more negative than above. Cool or not cool? All right, letter A, g of x dx from 2 to 2. Have I moved? You haven't moved, so this area is 0. Letter B, I start at 5 and I end at 1. So from 5 to 1 of g of x, negative 8, because from 1 to 5 of g of x was 8. Are we cool with that? Okay. Letter C is from 1 to 2 of f of x. Notice I have a 3 in the front, so I can move the 3 on the outside, and this is the same thing as 3 integral 1 to 2. You don't have to do this. I'm just showing it that we're just using one of the properties. So what is 3 times negative 4?
Negative 12.
Yep. Are we okay so far, guys?
Yeah.
All right. Letter D, from 2 to 5. Well, oh, Chavez, what do I do now? Relax. I want you guys to relax. Notice from 1 to 2, it is negative 4 for f of x. And from 1 to 5, it is 6 for f of x. Let me do a visual. Yeah, but let me do a visual. I'm not going to do the sign. I'm just going to make it all positive just so you guys can see. This is not this f of x. I'm right. Not this f of x. I'm just doing a visual for good notes. F of x, and I'm going to say this is 1, and I'm going to say this is 2, and I'm going to say that way over here is 5. We still okay? This is for good notes. So now look, I'm just doing this part, so let me go ahead and see. So I can say this, integral from 1 to 2 of f of x dx plus integral from 2 to 5 of f of x dx equals integral from 1 to 5 of f of x dx. Does that make sense to you guys? That if I add from 1 to 2 and I add from 2 to 5, that it's the whole shebang? Okay, look what this one is saying. It's saying that I just want the area from 2 to 5, just this part. So all you got to do is get the area from 1 to 5, which I have. It's this one right here in black. And subtract what region? Just 1 to 2. Good job. Do you guys see that? So here's what I'm going to write. For this, I'm going to put an equal sign, and let me put it in red. I'm going to put area from 1 to 5 of f of x dx, subtract the area from 1 to 2 of f of x dx. Does that make sense in your head? Okay, so here we go. That's going to equal, what's the area from 1 to 5 of f of x dx? 6 minus, what's the area from 1 to 2 of f of x dx? Negative 4. What is 6 minus a negative 4? 10. Cool. We did it, guys. All right. Letter E. 1 to 5 of f of x minus g of x. Let's see. Do we have 1 to 5 for both? We do. So I'm going to write, this is just integral 1 to 5 of f of x dx minus integral 1 to 5 of g of x dx. What's the area from 1 to 5 of f of x? Minus, what's the g of x? So what's 6 minus 8? There it is. On this one here, letter F, I'm going to change the color to blue because it might be kind of close to E here. This is just going to be, notice that the 4 is in front of the f of x. You can split it like this. 4, 1 to 5, f of x dx minus integral 1 to 5, g of x dx. Okay, so now what? 4 times 6 minus 8. 4 times 6 is 24 minus 8, 16. Are we feeling okay, guys? Okay. All right, let's see how many of these you guys can do. Not all of them are possible, if not possible. Go ahead and see if you guys can get ahead of me, and then look up whenever you're done with them. I do want to look at one of them real quick. Look at letter D. If they didn't tell us this, but if they would have said f of x is even, then we would have enough info to answer letter D. They don't tell us that, so because they don't tell us anything, we don't have enough information for letter D. That's why it says if possible, guys. Not all of them are possible. But what if it was even? What would be the answer? Do you guys know? 2.5. Do you guys know what even function means? Yeah. Even means symmetric on the y-axis. So if you're symmetric on the y-axis, between negative 1 and 1 it's 5. I'm just going to draw something very, very generic. Negative 1 and 1. It's like saying this. Here's a parabola, even function. So the area between negative 1 and 1 is 5. And it's an even function. So all of a sudden, if I cut it from 0 to 1, that means this in black, then it would just be half of that 5. Does that make sense? They've done it before where they tell you it's f of x is an even function, and then you'll be able to answer it. But if they don't tell you anything, not enough info. Cool? All right, keep going. Oh, the last 3 are not enough. Okay, here's the key, guys. The last 3 are not enough. Letter E and letter F, h of x is not included for the domain. See, h of x only goes between negative 1 and 1. You don't know what happens outside of negative 1 and outside of 1. That makes sense, guys? And then letter F, you can do f of x. But h of x you cannot do from 1 to 4 because you don't have that domain in there. ¿Cómo te sientes? Okay. All right, let's see what else we got. See, we're going through the pages pretty quick, guys. The regions A, B, and C in the figure below are bounded by the graph of the function f and the x-axis. The area of the region A is 18, so put 18 here. The area of the region B is 14, and the area of region C is 8. Okay, those numbers are unsigned area. If it's below the x-axis, I know that it's negative. If it's above the x-axis, I know that it's positive. Are we okay? All right. What is the value? So look what they want. The integral from negative 5 to 8 of f of x dx. So I start at negative 5. And I'm going to go all the way to 8. So I want that area. If it's below the x-axis, I'm counting regular, right? Negative 5 all the way to 8. So I'm going to say what? Negative 18 plus a negative 14. You could also say negative 18 minus 14 plus 8. Does everyone know why I wrote negative? Because you're below the x-axis. Cool? All right, add them up. Let's see.
I have a question.
18, 28. What's up?
Why would we not include, like, you know how there's like a concave up part between A and B?
Oh, yeah, but they're already telling. Okay, keep going.
Like, why would we not include, like,
They're talking about bounded area. So you're talking about like all this stuff here?
okay.
Yeah, that's not bounded. You want stuff between the curve and the x-axis. You know what I mean?
Yeah.
18, 28, 29, 31, 32, 32, and 8, negative 32, 24. Negative 24, right? All right, let's go to the next one. I think the rest is just this stuff with geometry. Yep. So you're going to need a little bit of geometry. All right. Same question. The area of the region A is 9, so this is 9. The area of region B is 8, so this is 8. And the area of region C is 4, 4. And the area of region D is 9, 9. Okay. So they want this time the area from negative 6 to 0 of f of x dx. Again, I'm going negative 6 to here to 0. So this is below the x-axis. So negative 9 plus 8, negative 1. Are we okay, guys? All right, let's go to the next one. The function f is shown below. So from negative 9 to 9. Okay, so now we're going to be doing a whole bunch of geometry. Let's see. Could we do a rhombus? It doesn't matter how you do it. I see a trapezoid. I see a rectangle, triangles. It doesn't matter. I see a big triangle here. So I'm just going to do 1/2 base times height. Do you guys see that? And then I see, what do you guys want to do here? A rectangle and a triangle? Or do you want to do trapezoid and a triangle? It doesn't matter. You'll get the same answer. Okay, so here's the trapezoid going up, right? So 2 plus 5 times 1, 2, 3 times 3 divided by 2. That's going to give me this, part 1. And then I see a triangle right here for region 2. So I'll color code it, guys, so you guys can all have nice colors here. Let's see, from negative 1 to negative 6, that's 5. So 1/2 times 5 times 5. And then plus, and we'll do this region, both of those regions, I'm adding them up. This, I should have put this as a dash so you don't confuse this as a, that's my height, that dash line of that triangle. So from negative 1 to 9, that's, so 1/2 times 10 times 3. There you go. 5, 6, 7, 7 times 3, 21, 21 over 2. Oh, 21 over 2 plus 5 times 25, 25 over 2 plus 30 over 2. Let's see, 30, 21, 30, 40, 50, 55, 65, 75, 76 over 2. So that's 38. How do we feel with that, guys? Okay, let's go to the next one. I see 2 trapezoids on this one. Or 2, yeah, it doesn't matter. All right, so this one they want from 1 to 9. Notice they're still counting. Okay, they're making it nice for us. So here's what I see. I see this trapezoid with this base there and that base there. Do you guys see that? So I see, let's see, from 1 to 9, so 8 plus 1, 2 times height, which is 2, divided by 2. Of course, all this is negative. So it's going to be, boop, negative 10. Does everyone know why it's negative? Okay. It's below the x-axis. I just did one trapezoid, but you can do a rectangle and triangles, or you can cut it up into 3 triangles. This guy there, 2 triangles and a square. It doesn't matter how you do it, guys. You'll get the same answer. So just no geometry. All right, 0 to 9. The function f shown on the right is comprised of a semicircle. All right, I love semicircles. So from 0 to 2, that's a semicircle. That's a quarter of a circle. And that's going to be negative. And then from... Yeah, that little part, look, this.
Oh, I thought you meant the whole thing.
And then from 0 to 9, from 2 to 9, that's a triangle. Okay, so here we go. So I'm just doing the quarter of a circle, so negative, and then pi r squared divided by 2, right? Divided by 4, sorry. So the radius is 2, so pi 2 squared divided by 4. Does everyone know where that formula came from? Okay. Plus, and then this is just a triangle. 1, 2, 3, 4, 5, 6, 7. So 1/2 times 7 times 3. So let's see. Negative pi plus 21 over 2. I would leave it like that. This part right here is below the x-axis. Everyone okay with that so far, guys? Okay. Given the function f graph, determine which of the listed integrals is less than all of the other 3. Okay, what? Let me see it again. Given the function f graph below, determine which of the listed integrals is less than all of the other 3. Okay, I think it wants me to choose the smallest integral. You guys ready? All right. I know between 0 and 2, that is a positive, and between negative 7 and 4, negative 4, that is a positive. So between negative 7 and 4, I'm going to put greater than 0. And let's see, do I have one that's going between 0 and 2? No. All right. Between negative 4 and 2, negative 4 and 2. Okay. Between negative 4 and 2, there is more area below the x-axis than above the x-axis. Here's what we're talking about, see? So I know this one, I'm looking at letter A. I know that letter A is smaller, is negative, right? All right, between negative 7 and 0, I know that there's still more negative, so that one's also smaller because it looks like there's more negative than above, correct? And then between 0 and 8, there's definitely way more negative than this little part that's positive. So this is definitely a big negative number. I think they want me to get the smallest one. So the smallest one is the one that is a big negative number. Let's see. Did that make sense, guys? All right. What's up, Gonzalez? Tell me. Yeah, the question says, determine which of the listed integrals is less than all of the other 3. All that means is which one is smallest. Remember that in the number line, the further left you go, the smaller you are. And then the farther right you go, the bigger you are. So you want the biggest negative number.
So like for A, because it's negative 1 and 2, it's below the x-axis, it's going to be negative.
It's going to be less than 0, but it's not a super big negative number because look at all this negative. You know what I mean? Yeah. All right, let's see what this one wants. Oh, I like this one. This one's forcing you to use a property. The region A, B, C, and D in the figure below are bounded by the graph of the function f. And these are the only questions you can do right now with actually do an antiderivative, right? The area of which of the enclosed regions are labeled in the figure with the respective number of, well, okay, blah, 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 whatever. All right, they want to know what this is. Break this up like this, guys. Integral from, let me use red again. Integral from negative 1 to 8 of f of x dx minus integral from negative 1 to 8 of 4 dx. At the moment, the only antiderivatives you can do are just constants. This I can do with the images to the left or to the right. Man, I don't know left and right. And this I can do with just a rectangle, right? Remember what this means, guys. I'll write it over here. So look, here's my image. Here's -1. Here is 8. Here is 4. That's just a rectangle, guys. Find me that area, right? So here we go. -1 to 8. So -1 is right here and 8 is right here. So what is that number? 3. So -3 plus 9 minus 8. Does everyone know where I got those numbers from? Okay, you see this number down here? It says 3. So the area between -1 and 1 is 3. But because it's below the x-axis, I got to say -3. The area between 1 and 4 is 9. So from -1, right? So you're going from -1 all the way to 8. I'm not done yet, because I still need this guy. What's up? I'm adding the area under the curve, no? Why would I be multiplying them? I'm finding area under the curve. Yeah, if I were to go from -1 to 4 of f of x dx, that would just be -3 plus 9. Okay, we're good? Okay. This is just for this integrand. Still okay, Gonzalez? Of how you say an integral? Yes. Okay, minus, okay, here we go. What is this? From 8 to -1, that is 9. And 9 times 4 is? 36. Let's see what all that is. -3 plus 9, that's -6, 8, 9, 10, 11, 12, 13, 14, -14, 36, 46, 49, 50. -50, let me know. I make mistakes all the time. I didn't get, you guys didn't get? Oh man. Let me do it again. -6 minus 8. 8. Oh, yeah, it's 6. It's 6 minus 8. -2. My bad. Sorry, guys. I was counting these and counting that as -6 for some reason. Yeah, you guys. Yeah, I make mistakes all the time, guys. 6 minus 8, -2 minus 36, -38. Yeah. What's up? Yes. This, you see this right here? From -1 to 8 of 4. So here's my f of x of 4 all the time. And I just put a -1 and I just put an 8. So I want to know the area of this right here in blue. So the difference between 8 and -1, that's 9. And then 9 times 4 is 36. Do you see how I did it? Okay. All right, let's go to the next one, guys. Is this the last one? All right, last one. Let f be a continuous function, 7 to 9. All right, see if you guys can tackle this one, and then we'll do it together. Yes, you do. Think about it. Draw a visual.
Yes, I do. I think I know what it is. Wait. No.
We'll do it together in a little bit. Draw a visual. Just draw everything above the x-axis. Don't worry about the numbers. All right, let's start tackling. If you know what you're doing, keep going. So here it is. I draw a visual. I do not care about these numbers. Don't you do the same. Don't worry about those numbers. Let your, most people are visual, So this, you'll understand. So look, this is what you care about, those limits. So let's think about it. Look what they want. Notice that they want from 7 to negative 6. So they want, what do they want? I want to figure out if I can know this in black. Well, right now, I know from 7 to 9. So I know this in blue. And I know this in green from negative 6 to 9. All that right here. So if I want to go from negative 6 to 7 or from 7 to 6, that means I got to get everything in green and subtract the stuff in blue. Do you guys see that? So here's what I'm going to do. I'm first going to do this. I'm just going to go, I know that I can get the area between negative 6 and 7 of f of x dx if I get the area from negative 6 to 9 of f of x dx, and I subtract the area from 7 to 9 of f of x dx. Does that make sense to you?
Yes.
Okay. The area from negative 6 to 9 is negative 2. Minus the area from 7 to 9 is negative 7. Yes or no?
Yeah.
So now, let's see, minus a negative. So it's going to be plus. So negative 2 plus 7. 5. So here's what you know. Integral from negative 6 to 7 of f of x dx is 5. That's all you need. You ready? What do they want? I'm going to come up and I'm going to write, they want from 7 to negative 6. I'm going to put the 1/3 in the front of f of x dx. So all I got to do is negate it. Negate the 5 to a negative 5 and multiply it by 1/3. So I'm going to write 1/3 integral from 7 to negative 6 of f of x dx equals, and I'm going to put the notes here, 1/3 times a negative 5. I'm going to put the word negate, which means just switch symbol. Equals negative 5. What am I negating? I'm negating that. Negative 5/3. How do we feel? Okay. I need to make sure that we don't feel overwhelmed. Do you feel overwhelmed today?
No.
Okay, so are you happy that we did this today and then tomorrow?
I feel like kind of good that we did a bunch of stuff today because it's like a good understanding. A
Okay.
good like foundation.
I'm about to hit you with delta. Tomorrow we're going to do the same thing, but it's a whole bunch of sigma notation. We're going to do the proof as well. Bring your A game tomorrow, guys.